If you brushed your teeth today, then congratulations. You've started your morning with one of the most reactive elements on the entire periodic table. Fluorine. A pale yellow gas so aggressive that it can eat through glass, react explosively with water, and even burn steel. Yet somehow, this same dangerous element is responsible for that fresh, minty feeling in your mouth. Strange, right? How does something so destructive become part of something as harmless as toothpaste? Stick around, because what fluorine can do, both in your mouth and across the world, is one of the wildest stories in chemistry. Fluorine, represented by the letter F on the periodic table, was first isolated in the late 1800s after decades of failed and often tragic attempts. The chemists who tried to capture this element called it the devil's gas, because it literally attacked everything they used to study it. Glass containers shattered, metals corroded, and even the scientists themselves got injured by its fumes. It wasn't until a man named Henri Moissan in 1886 used an ingenious electric method to isolate pure fluorine for the first time, earning him a Nobel Prize and the respect of terrified chemists everywhere. But what makes fluorine so intense? It's all about its hunger for electrons. Fluorine is the most electronegative element known, meaning it's the greediest of them all when it comes to attracting electrons from other atoms. That's why it forms some of the strongest chemical bonds in existence. Once it grabs onto another element, it almost never lets go. This property, although dangerous in its raw form, makes it incredibly useful when handled safely. Now here's where it gets fascinating. In your toothpaste, you'll find compounds like sodium fluoride. These are stable, tamed versions of fluorine that help protect your teeth from decay. When fluoride ions meet your enamel, they strengthen it by forming a tougher material called fluorapatite. That extra protection keeps acids from eating away at your teeth after you've enjoyed a soda or a sweet snack. So the same element that can burn metal is also the reason your smile can last a lifetime. Quite the plot twist, isn't it? But fluorine's story doesn't end in your bathroom. This element is deeply woven into modern technology. Without it, you wouldn't have non-stick pans, waterproof jackets, or even the refrigerants that keep your fridge cool. Fluoropolymers like Teflon rely on those ultra-strong carbon-fluorine bonds, making them resistant to heat, corrosion, and almost everything else. It's like having an invisible shield made of chemistry itself. And speaking of shields, fluorine even plays a role in medicine. Certain anesthetics contain fluorine atoms to make them safer and more effective. Some modern antidepressants and antibiotics rely on fluorine to improve their performance inside the human body. It helps drugs last longer and reach their targets more efficiently. It is almost poetic that something once seen as uncontrollable chaos now saves lives in operating rooms and hospitals. Here's a mind-bending twist. During World War II, fluorine became a key player in the nuclear age. Scientists used it to create uranium hexafluoride, a compound that made it possible to separate uranium isotopes for the first atomic bombs. So fluorine isn't just in your toothpaste, it helped shape world history. If you didn't know that, drop a comment saying, "I didn't see that coming," because this little element deserves its own thriller movie. But there's a dark side too. Some fluorine compounds, especially when misused, can cause environmental harm. Certain refrigerants that once relied on fluorine contributed to the destruction of the ozone layer. Thankfully, newer fluorine-based materials are being designed to be safer and more sustainable. Science, after all, keeps learning from its own chemistry. What do you think? Should we keep using fluorine in modern tech, or is it time to look for alternatives? Tell me your opinion down in the comments. I'd love to hear where you stand. So next time you brush your teeth or cook an egg on a non-stick pan, remember, there's a little bit of controlled chaos helping you out. Fluorine may be small, but it's fierce, clever, and absolutely vital to our way of life. If you learned something new today, don't forget to hit the like button and subscribe for more stories where science meets everyday magic. And tell me, which element should I talk about next? Because if fluorine can go from a killer gas to a dental hero, imagine what the rest of the periodic table is hiding.